All right, we've talked a lot about different integration techniques. We said in chapter 15 that there was no such thing as product rule, there was no such thing as quotient rule, and there was no such thing as chain rule, right? But then we kind of learned use substitution. And we said that a lot of times when we see kind of a chain rule problem, a lot of times that ended up being a use substitution problem, where we could call a quantity u, figure out what the derivative was, and see if we can substitute those in, use substitution, to help us make it into a more simplified problem that we could integrate. Well, today we're going to talk about kind of the reverse of product rule, where we've said so far that there is no such thing as product rule for integration. Well, today we're going to learn a technique where there might be. It's called integration by parts. And so if you remember the product rule for derivatives, when I go to take the derivative of two functions being multiplied, I really do the first times the derivative of the second plus the second times the derivative of the first. Remember that product rule? Well, we can actually reverse that product rule for integration, and what we end up getting is what we call integration by parts. Now, in integration by parts, there's a couple of different pieces we've got to do first. You might notice that we have a u, we have a dv, and what that does is when I integrate u dv, I end up getting u times v minus the integral of v du. Those are a lot of different pieces, right? And so what we have to do when we get a problem and it looks like a product rule, but we're integrating, what we need to do is figure out what our integration by parts is, all of our different pieces. That means we need a u, we need a dv, we need a v, and a du. We need all of those different pieces. So there are a couple of different steps that you should follow anytime we're going to use integration by parts. Step number one is we need to figure out what u is going to be. And there's kind of a trick that we can do. I'm going to use the letters L, A, E. L meaning logs or natural logs. I'm going to call u my natural log if there's a natural log in my problem. A lot of times, if there's a natural log in my problem, that's typically the quantity that we're going to call u. If there is no log or natural log, then I can start to use the algebra stuff in my problem. X's, any sort of polynomial with variables, if there's any sort of algebraic expression, that's probably what we're going to call u. If there's no logs, if there's no algebra, then maybe there's some sort of an exponential function or an exponential expression. We'll use that last. So once we decide what our u is going to be, then we're going to find our dv. Again, you notice that we need to have a u and then we need to have a dv. So dv is typically the rest of the stuff that I didn't use for u. I'm going to decide what my u is, and my dv is going to be the rest of my stuff. Once I have a u, I should be able to find the derivative of u, du. Once I have a dv, I should be able to find the integral or find v. If I'm given the derivative of v, dv, we should be able to work backwards and find what v is by taking the integral. Once I have all four of those pieces, I can then plug all four of those pieces into this integration by parts formula. And that'll help me figure out what the integral is of the original problem. Let me show you a few examples. In example number 1, we are integrating x times e to the 5x with respect to x. Maybe you noticed that I have a variable here, x, times another function with a variable. What I have here is a product rule. If I tried to use u substitution, it wouldn't quite work out and I would have some extra x's in there that I couldn't get rid of. So u substitution wouldn't work in this problem. But once I notice that it's a product rule, I can always try to use my integration by parts. Remember, my integration by parts formula looks like this. The integral of u dv is equal to really u times v minus the integral of v du. So what we have to do is find all four of those parts. Remember, we're going to decide what u is first, and then we're also going to decide what our dv is. In this problem, remember L, A, E. I noticed that there was no log or natural log. So then I'm going to look for some algebraic stuff, expressions, right? And so I noticed that there was an oops, I don't want to use that. Let's use this instead. I noticed that there was an x in my problem. That's an algebraic expression. That's some sort of a polynomial. So I'm going to use x as my u. That means the rest of my problem is going to be my dv. Remember, it's u times dv. So I'm going to call u x, I'm going to call dv my e to the 5x dx. Once I have u, I should be able to find the derivative of u, right? What is the derivative of x? The derivative of x is 1, or 1 dx, right? If I have dv, then I should be able to work backwards, or integrate, to find v. So we've got to remember all of these different, not only derivative rules, but integration rules that we've learned so far. And you've got to train your brain to go forward and backward all in the same problem. A little bit difficult, so make sure that you practice these. So we found the derivative of x, which is 1 dx, but now we have to find the antiderivative of e to the 5x. If you remember, the antiderivative of e to the 5x, e to the kx, e to the anything x, is really e to that kx, e to the 5x, divided by 5, that k, right? We've talked about that rule in a previous section. So the antiderivative of e to the 5x is e to the 5x divided by 5. Now I have all four pieces. I have u, du, I have v and dv, and now I can plug it into my formula. My formula says that u, which is really x, and dv, which is really e to the 5x dx, that's what my original problem was, but I didn't know how to solve this problem. If I don't know how to solve this problem, then I should be able to use the rest of the integration by parts formula to tell me what it equals. So the integral of x e to the 5x dx is really the same thing as u times v minus the integral of v times du. So let's plug in those four pieces. My u was x, my v was e to the 5x over 5, minus the integral of v, which is e to the 5x over 5, times du, which is 1 dx. So I use my four pieces and plug them into the formula. I'm going to simplify now. Looking at this first piece here, it looks like I have an x times an e to the 5x all over 5. Not really much I can simplify on that piece. On my second piece, it looks like I have the integral of e to the 5x over 5 times 1. Or could I really just say e to the 5x over 5 dx? I also noticed here that there was an invisible 1, or a 1/5 as a coefficient. I'm actually going to take that coefficient then and bring it out to the front and then just integrate the rest of my integral, which is e to the 5x dx. That's a lot easier than trying to deal with that fraction or that denominator underneath. I can take out the 1/5 because it's just a coefficient, just a number, no variables, and then I can just integrate the rest of my problem. I can find the integral of e to the 5x. Remember, we talked about this rule just a second ago. The antiderivative, the integral of e to the 5x, is really just e to the 5x divided by 5. Don't forget, though, you have a 1/5 out in front that I need to multiply eventually through by that expression. Also, don't forget, anytime we're integrating, we need to make sure that we add that constant of integration, that plus c. So here's my first little piece, here's my second little piece, and then don't forget your constant of integration. So that means the integral of x e to the 5x is really going to be x e to the 5x over 5 minus e to the 5x over 25, that was my 5 times 5, plus c. So I can integrate something that looks like a product rule. I just have to make sure I use integration by parts. Making sure, again, you follow those four steps. Find your u. Remember the letters L, A, E. That'll help you get started with what u is going to be. Then find the rest of it, which is dv. Once you have u, find your du. Once you have dv, find your v, and then plug those pieces into the formula. I will be giving you the formula on your exam, but make sure you know how to use the formula. Okay, so hopefully you practice so that that formula doesn't look unfamiliar to you, that you can follow those four steps, you can plug it into the equation so that we can integrate problems that might look like product rule, even though we don't have a reverse product rule. We kind of do now, we just have integration by parts. We'll do another example in the next video.